Imagine, for just a moment, that the universe is looking back at us. In the first 10 seconds, I want you to picture a pair of ancient ice colossal, timeless watching from the other side of the cosmos. Not stars, not galaxies, but something deeper, stranger, and beyond explanation. That's what astronomers felt when James Webb sent back a signal that didn't quite fit the rules of reality as we knew them. Take a deep breath, let your shoulders relax, your jaw soften. Tonight, I'll guide you into a story that feels like science, but whispers like a dream. It's a story about a golden mirror drifting a million miles from Earth, staring into the cosmic dark, and catching a glimpse of something no one expected. This is the story of the James Webb Space Telescope and the mystery that even the brightest minds struggled to explain. When we speak about James Webb, we're not just talking about another telescope. We're talking about the largest, most ambitious eye humanity has ever built to peer into the unknown. Unlike Hubble, which showed us wonders like the pillars of creation in crisp detail, Webb goes deeper beyond visible light, into the infrared spectrum. That's where the faint whispers of ancient galaxies still echo. Infrared light stretches across the fabric of time, carrying secrets from stars born nearly 13.5 billion years ago. Webb was designed to listen to those whispers, and yet, sometimes it catches voices we weren't prepared to hear. But before we dive into the strange signal Webb uncovered, let's slow down. Like travelers pausing before entering a dark forest, we need to understand where this story begins, not with Webb floating silently in space, but with an idea planted decades ago. The dream of James Webb began long before its golden mirrors were polished. Back in the 1990s, as Hubble dazzled the world with its breathtaking images, scientists realized they needed something more. Hubble could only see so far, and while it showed galaxies forming, it couldn't peer into the first flicker of light after the Big Bang. To get closer to the origin of everything, they needed a telescope that didn't just orbit Earth, it needed to escape Earth's heat, its atmosphere, its distortions. The challenge was daunting. How do you build a telescope larger than any rocket can carry? The answer was Webb, a machine that could fold up like an origami creation, launch aboard a rocket, and then slowly unfurl in the silence of space. And yet, for all its beauty, Webb was also a gamble. Many called it the telescope that could never work. It was delayed for years, its budget ballooning from hundreds of millions into billions. Politicians debated canceling it. Engineers worried a single mistake could ruin everything. Because Webb was not serviceable like Hubble. If it failed to unfold, if one screw came loose, if one panel stuck, it would drift uselessly in space, a $10 billion monument to broken dreams. But somehow, humanity pushed forward. Piece by piece, Webb was built. Each mirror segment was polished with almost divine precision. Each instrument was tested under freezing temperatures, simulating the vacuum of space. It became not just a telescope, but a symbol of human determination, a reminder that even when failure seems inevitable, hope can stretch further. When December 25, 2021, arrived Christmas morning, the world held its breath. The Ariane 5 rocket lit up the sky, carrying Webb into the darkness. As the telescope began its journey, millions of us wondered, would it survive? Would it bloom like a golden flower in the void? Or would it vanish, leaving silence in its wake? The first stages were successful, but then came the true test. Deployment. Imagine thousands of steps, all choreographed in perfect order, each one needing to succeed. First, the solar array unfolded, then the sunshield, with its 5 delicate layers, stretched out like silver wings. Then, slowly, the golden mirrors began to align, each one tilting with microscopic precision. It was like watching an ancient ritual in the sky, a transformation, a machine becoming an eye. Day by day, tension melted into relief. Engineers cheered as every step succeeded. Webb was alive. It drifted to its home L2, a point a million miles from Earth, where the gravity of the Earth and Sun balance in harmony. There, in the cold silence, it opened its eye, and then, it began to see. The first images shocked the world. Webb revealed galaxies stacked upon galaxies, spiraling, colliding, stretching across infinity. Where Hubble had shown a handful of galaxies, Webb revealed thousands in a single frame, tiny pinpricks of light that weren't stars, but entire galaxies, each containing billions of suns and countless worlds. Some of these galaxies were so old, they formed just a few 100 million years after the Big Bang. Humanity had never seen that far back in time before. It was a triumph, a miracle of engineering. But within those first breathtaking discoveries, buried in the data, astronomers found something odd, something that didn't fit. Patterns in the light. Objects that seemed too bright, too massive, too early, and whispers of signals that felt almost like an echo that shouldn't exist. We'll return to those signals soon. For now, let's linger on the quiet awe Webb stirred, because that's where this mystery truly begins, not with fear, but with wonder. When the first images from Webb swept across the world, people gasped, some even cried. There's a strange, almost spiritual weight that comes from realizing how vast the universe really isn't, how small we are in comparison. But among the waves of wonder, scientists began to whisper about something stranger than beauty. One of the first puzzles appeared in what astronomers call the early universe problem. According to decades of theory, galaxies take time to grow. They start small, faint, chaotic, yet Webb's infrared vision revealed massive galaxies appearing shockingly early, just a few 100 million years after the Big Bang. It was as if skyscrapers had appeared overnight in a city that had only just been founded. This discovery made astronomers pause. Did we misunderstand how galaxies form? Was gravity working differently in the beginning? Or was there something else, something hidden shaping the cosmos in ways we hadn't imagined? As data poured in, more mysteries surfaced. Webb detected structures in galaxies far too well organized for their age. Spiral arms, central bulges, even hints of black holes anchoring their cores. According to the timeline of the universe, these things shouldn't exist yet. But there they were, clear, undeniable, shimmering in Webb's golden eye. And then came the odd signals. Webb's instruments don't just take pictures, they also dissect light, breaking it into spectra. Imagine a rainbow stretched thin, revealing every fingerprint of an atom or molecule. With these fingerprints, scientists can tell what distant stars and galaxies are made of, how fast they're moving, and how far away they are. But in several observations, Webb detected patterns in the light that didn't match known elements or expected redshifts. The signals seemed off, like a musical chord played slightly out of tune. To most of us, these oddities would be easy to dismiss as technical glitches, but astronomers are careful. Webb's instruments are the most precise ever built, cooled to near absolute zero to eliminate interference. Every pixel, every photon, is accounted for. So when a signal looks wrong, it demands attention. One such observation came from a region astronomers call the cosmic dawn, the era when the first stars and galaxies flickered into existence. Webb detected sources of light, so bright they almost defied physics. It was as if someone had turned on a floodlight in a time when only candles should exist. These weren't just ordinary galaxies, they were giants, bursting with energy, living too fast, too soon. Theories began to stir. Some scientists suggested exotic dark matters, something beyond the particles we know might have accelerated the birth of these galaxies. Others whispered about errors in our cosmological models, even questioning the very expansion rate of the universe. And in the quiet corners of discussion, a few dared to ask, what if these lights weren't entirely natural? Now, to be clear, astronomers are cautious. Science demands restraint, evidence, and patience. But humans are dreamers. When confronted with signals that defy expectations, the imagination wanders. Could these bright lights, too massive for their age, be signs of something artificial? Civilizations, perhaps, burning with the power of stars themselves. It sounds like science fiction, and maybe it is. Yet part of Webb's mission is to look for biosignatures, chemical hints of life in alien atmospheres. If Webb can sniff out water vapor, methane, or carbon dioxide on distant planets, why couldn't it stumble upon something stranger, an echo of technology written in starlight? But let's not leap too far ahead. For now, the oddities remain unexplained, waiting like riddles in the sky. And while the scientific community debates, you and I can sit here together, floating in the thought of it. Imagine lying under the stars on a summer night, but instead of seeing constellations, you realize those lights might not just be suns. Some of them could be beacons, signals, messages written in the oldest language, light. Beyond galaxies, Webb also turned its eye toward exoplanets, worlds orbiting distant suns. In one early triumph, it captured the spectrum of an exoplanet's atmosphere, detecting water vapor and clouds. For the first time, we weren't just guessing if alien skies could hold rain, we had proof. Yet once again, something unexpected appeared. The chemical fingerprints hinted at conditions that didn't quite add up, as if the planet's atmosphere carried a recipe we didn't know how to read. Layer by layer, Webb is painting a picture of a universe stranger than we dared to dream. Every observation seems to peel back a curtain, revealing not certainty but deeper mystery. And maybe, that's the point. Maybe the universe doesn't exist to be solved like a puzzle, but to invite us into endless wonder. Still, those whispers of unexplained signals haunt the background. They remind us that Webb may be more than just a telescope. It might be a messenger, carrying stories across billions of years. Stories we are only beginning to hear. So let's drift deeper into this mystery together. As you listen, let your breath slow, your body sink into stillness. Imagine yourself aboard Webb, drifting a million miles from Earth, shielded from the sun, surrounded by silence. In that silence, something stirs, a light, older than our world, carrying a message humanity has not yet deciphered. This is where the story of something beyond explanation truly begins. As Webb continued its gaze, astronomers refined the data, calibrating instruments, double-checking results, ruling out noise. But the strangeness remained. One dataset in particular caused a quiet stir in research circles, a pattern in the light that repeated, like an echo. Imagine shouting into a canyon and hearing not one, but two returns, slightly distorted. That's what the spectrum looked like. a mirror image layered within itself, as if the light carried a shadow. What could cause such a phenomenon? Some suggested gravitational lensing, where massive objects bend light and create duplicates of distant galaxies. Others considered instrumental quirks, though Webb's design leaves little room for error. Yet the possibility lingered that something in the early universe was imprinting itself into the very photons Webb was catching an invisible hand, reshaping light across billions of years. For those who study cosmology, this was both thrilling and unsettling, because every anomaly forces a choice: adjust the data to fit the theory, or reshape the theory to fit the data. And reshaping a theory can mean rewriting our understanding of reality itself. Meanwhile, beyond the technical debates, the public imagination ignited. Headlines asked if Webb had glimpsed impossible galaxies. Commentators speculated about hidden forces, parallel universes, even alien megastructures. Scientists rolled their eyes, but inside, many admitted, the truth really was stranger than expected. One astronomer described it best: "It feels like opening a history book and finding skyscrapers in the Stone Age." That's the level of shock Webb delivered. Structures too large, too bright, too fast. It was like the cosmos was skipping steps, accelerating through its own growth in defiance of every model we trusted. But perhaps this is the lesson the universe always teaches: humility. Each time humanity thinks we've mapped the cosmos, it shows us how little we know. Copernicus, Galileo, Einstein, all faced moments when the universe seemed to say, "Look again." Maybe Webb's unexplained discoveries are another one of those turning points. And yet, there's another way to look at this. What if these mysteries are not glitches or mistakes, but invitations? What if the cosmos is whispering, nudging us to expand our imagination? Close your eyes for a moment. If you like, picture yourself floating in that endless darkness, surrounded by galaxies too numerous to count. Some are ancient and dim, some bright and newborn. Somewhere among them lies the unexplained. Perhaps a cluster of stars shining too fiercely, or a signal shaped like no natural process we've seen before. You drift closer, feeling the weight of time itself in the light. What you sense is not chaos, but design. Not answers, but questions woven into the fabric of reality. That's where Webb takes us, not just to new knowledge, but to deeper wonder. It forces us to ask, are we witnessing nature's creativity, or something more? Could there be structures out there, not born of physics alone, but of intelligence? Or is the intelligence we sense simply our own, mirrored back at us by the universe's complexity? For now, there is no clear answer. Scientists continue to gather data, refine their models, debate late into the night. But the beauty of Webb is that it doesn't rush. It sits patiently at its post, drinking in the light, frame by frame, year by year. Somewhere in that stream of photons may lie the clue we need. And perhaps the most mysterious part is not what Webb has already seen, but what it will see. The telescope is just beginning its mission, with decades of discovery ahead. New exoplanets, hidden galaxies, and maybe signals that truly defy natural explanation. So, as you drift deeper into this story, let yourself relax into that sense of vastness. Feel the humility of being part of something so much larger. Imagine that golden mirror, far beyond Earth, reflecting light that has traveled billions of years to meet us. Within that light, within those faint patterns and anomalies, lies a promise that the universe still holds secrets, and that we are just at the beginning of learning them. And as strange as those secrets may be, perhaps the real mystery is this: why do they make us feel less afraid, and more at peace? When the first wave of James Webb's data arrived on Earth, most astronomers expected beauty, not shock. They anticipated breathtaking vistas of galaxies, sharper than anything Hubble could provide. They looked forward to refining the timeline of cosmic history, to polishing details rather than rewriting the book. But within months of its debut, Webb delivered something else entirely, an unsettling contradiction. The telescope's deep-field surveys revealed galaxies that should not exist. According to our best models, the early universe was a chaotic fog. Stars were just beginning to form. Galaxies should have been small, irregular, faint tiny building blocks scattered across the void. Yet Webb's golden eye captured massive, mature galaxies, shining bright only a few 100 million years after the Big Bang. It was as though Webb had opened a family photo album and discovered skyscrapers and baby pictures. These galaxies were simply too large, too structured, too luminous to fit the timeline we believed. One researcher put it plainly: we found galaxies that shouldn't be there. And that wasn't all. In the spectra, the fingerprints of light that reveal chemical makeup, Webb detected unusual signatures. Some stars seemed too heavy, too metallic, as though they had lived through multiple generations of star birth and death, yet there hadn't been enough time for that process to unfold. In other words, these systems looked old, in a universe that was still supposed to be young. The anomalies piled up. One dataset appeared to show star formation rates 10 times higher than expected. Another suggested black holes had grown far faster than theory allowed. And tucked away in the margins of Webb's results were even stranger whispers. faint irregularities in the background light, small deviations that resisted explanation. Astronomers double-checked everything. Could it be calibration errors? A trick of the instruments? Data pipelines were scrutinized, simulations rerun, models adjusted. Yet time after time, the signals remained. Webb was not mistaken. The universe itself was misbehaving, or perhaps, our understanding of it was incomplete. Behind closed doors, scientists debated late into the night. Some urged caution, insisting that extraordinary claims required extraordinary evidence. Others were quietly thrilled, recognizing that anomalies are often the seeds of revolutions. It was reminiscent of the days when Galileo's telescope first revealed moons circling Jupiter, challenging centuries of dogma. Back then, the evidence seemed unthinkable too. Meanwhile, beyond academic journals, whispers escaped into the public sphere. Reports spoke of impossible galaxies, cosmic rule breakers, even evidence of hidden physics. News outlets amplified the mystery, and imaginations caught fire. Could these be hints of parallel universes bleeding into ours? Traces of advanced civilizations shaping stars and galaxies on unimaginable scales? Or was it simply nature reminding us that it plays by rules we have yet to grasp? For the scientists working with Webb, the stakes were high. Billions of dollars, decades of effort, and countless careers were invested in this telescope. Its findings could either refine our understanding or force us to tear apart the very foundation of cosmology. And here's where the story grows even stranger. Because buried in the early data was something even more puzzling. A repeating pattern, almost like an echo, etched into the light. To the untrained eye, it looked like noise, but to those studying the spectra, it appeared deliberate, structured. Light wasn't just carrying information about distant stars, it seemed to be whispering something else entirely. For now, no one dared to call it a signal. That word carries too much weight. But in hushed conversations, in private corners of conferences, scientists admitted it felt like the universe itself was trying to get our attention. And so, Webb's story shifted. It was no longer simply about imaging the cosmos. It was about confronting the unknown, about staring into the darkness and finding not emptiness, but questions. Questions that didn't just challenge physics, they unsettled our sense of place in the cosmos. As you settle deeper into this story tonight, imagine what it must feel like to be one of those scientists. Sitting alone in a quiet lab, sifting through ancient light. You expect clarity, neat answers, numbers that align with theory. Instead, you find patterns that don't belong, galaxies that shouldn't exist, echoes that refuse to fade. What would you feel? Wonder, fear, a strange, intoxicating mix of both. Because that's where we stand tonight. On the edge of a mystery. Webb has shown us beauty, yes, but also dissonance. A cosmic melody with notes out of tune, inviting us to listen closer. When the impossible galaxies first appeared in Webb's deep field images, the astronomical community split into two camps. On one side were the traditionalists, those who had spent their lives building the standard model of cosmology. For them, the lambda cold dark matter model CDM was nearly sacred. It explained the expansion of the universe, the formation of galaxies, the cosmic microwave background. To accept Webb's results as literal would mean reworking decades of theory. And that was something they were not ready to do. On the other side were the explorers, the scientists who looked at anomalies not as threats, but as opportunities. For them, the data was exhilarating. If galaxies were forming earlier, larger, and faster than predicted, perhaps it was time to imagine new physics. Maybe dark matter behaved differently than assumed. Maybe cosmic inflation had quirks we hadn't considered. Or perhaps there was something even stranger, hidden beyond the horizon of our imagination. The debates were fierce. At conferences, presenters would show Webb's image two tiny bright spirals glowing in the first few 100 million years after the Big Bang. Murmurs would ripple through the audience. One scientist would argue that the galaxies were being mismeasured, that their brightness made them look bigger than they truly were. Another would counter that no matter how you sliced the data, the numbers didn't lie. The galaxies were simply too massive for the timeline. Some proposed an adjustment to the laws of star formation. Maybe stars could form more efficiently in the early universe, clumping together in giant clusters. Others wondered if black holes were the key massive seeds that grew quickly, pulling galaxies into order far earlier than expected. But even these ideas stretched the limits of plausibility. Then came the radical hypotheses. A few voices whispered that perhaps our universe was not alone. If parallel universes existed, their gravitational fingerprints might bleed into ours, nudging galaxy formation along. Others speculated about dark stars, exotic objects powered not by fusion, but by the annihilation of dark matter. These dark stars, if they existed, could shine brightly and grow rapidly, explaining the strange observations. And in the background, always, there was that repeating pattern, the echo embedded in the spectra. Some dismissed it as a processing artifact, a quirk of the detectors. Yet, the more it was studied, the harder it became to ignore. The pattern was subtle, almost like a rhythm, weaving through the light. It had no clear origin, no natural explanation. To even suggest it might be intentional was dangerous, scientifically reckless, some said, but in private, the thought lingered. What if we were seeing not just galaxies, but a message? Publicly, of course, the conversation stayed grounded. NASA released carefully worded statements about unexpected findings and exciting challenges to current models. Press briefings emphasized the beauty of the images rather than the dissonance in the data. But beneath the polished surface, scientists wrestled with something deeper. Were they on the verge of a paradigm shift? The last time astronomy faced such a moment was nearly a century ago, when Edwin Hubble discovered that galaxies were moving away, proving the universe was expanding. Before that, when Einstein introduced relativity, the very fabric of space and time had to be rewritten. Webb's results carried the same potential, the possibility that our cosmic story was incomplete, or perhaps even wrong. For young researchers, it was thrilling. Careers could be made on solving this puzzle. For veterans, it was more complicated. Entire lifetimes of work were built on the foundation of a model that now seems shaky. Was it arrogance to cling to old theories, or wisdom to avoid chasing illusions? And then, there was the human side. Imagine being in the control room, watching the data stream in from a telescope a million miles away. Imagine the quiet weight of realizing that something in the universe doesn't fit. That your job is to tell the world what you've seen, even if it contradicts everything we thought we knew. That mixture of awe and dread of standing at the edge of discovery. Unsure whether you re-glimpsing truth or falling into error haunted many who worked with Webb's data. Slowly, papers began to emerge. Preprints circulated online, sparking heated debates. Titles ranged from cautious, constraints on early galaxy formation, to provocative, challenging the standard model of cosmology. Each new paper added fuel to the fire, and each was met with critiques, rebuttals, counter-analyses. The scientific process was playing out in real time, messy, passionate, alive. And yet, through all the noise, one thing was clear. Webb had changed the game. Even those clinging to the old models admitted that adjustments were needed. The telescope was too powerful, its data too precise to be ignored. Something was happening in the early universe that we had not accounted for. Something fundamental. What if gravity behaved differently in those first few 100 million years? What if the constants of physics were not as constant as we believed? Or what if, most unsettling of all, the universe was far stranger than we ever dared imagine? As you drift deeper into this story, picture the scientists themselves not as distant figures in lab coats, but as human beings lying awake at night, staring at the ceiling, turning these questions over in their minds. The data is real, the contradictions are undeniable, and the answers, for now, remain out of reach. Outside the walls of academia, the discoveries of the James Webb Space Telescope took on a life of their own. News outlets splashed its images across headlines, often with dramatic phrases, "Galaxies that shouldn't exist," "The universe's impossible dawn." To the public, the story was irresistible. For decades, astronomy had promised answers about the cosmos, and now, it seemed, those answers were unraveling. People who had never cared about astrophysics suddenly found themselves captivated. Social media feeds filled with Webb's golden, jewel-like images, the vibrant swirls of distant galaxies, rendered with detail no human eye had ever seen before, spread virally, and with them came speculation, wild creative, sometimes conspiratorial. Some internet forums buzzed with the idea that Webb had captured evidence of extraterrestrial civilizations. After all, if galaxies were forming too fast, too soon, perhaps advanced beings had a hand in shaping them. Threads appeared, claiming the echo pattern in the spectral data resembled an artificial signal, a cosmic broadcast. Others drew connections between Webb's findings and ancient myth stories of gods who seeded the stars, or civilizations that rose and fell before time began. Mainstream science dismissed these ideas, of course, but for the public, they carried a certain allure. Mystery breeds imagination, and when official explanations feel incomplete, people reach for stories that make sense of the unknown. The more cautious NASA appeared in its language, the more some suspected that something was being hidden. Documentaries, podcasts, and late-night radio shows seized the moment. Theories ranged from the plausible like new physics waiting to be discovered to the extraordinary, such as the universe being a simulation designed by higher beings. The phrase beyond explanation stuck in the public mind. It was a reminder that even with our most advanced technology, there were places where human knowledge faltered. For scientists, this attention was both a blessing and a curse. On one hand, the excitement drew new interest to astronomy, inspiring students to pursue research. On the other, it blurred the line between science and speculation. A careful debate over galaxy formation could quickly be drowned out by headlines about alien architects or hidden universes. Still, there was no denying the emotional power of Webb's images. People looked at them and felt small, humbled, yet strangely connected to something vast. They were reminders that our everyday worries, though heavy, existed inside a universe of staggering beauty and mystery. Some even described the images as spiritual experiences, windows into creation itself. Meanwhile, researchers continued to wrestle with the data. Some teams began re-examining the fundamental assumptions baked into their models. How light travels across expanding space. How cosmic dust obscures or magnifies distant objects. How quickly stars can burn hydrogen in their cores. Each variable became a potential lever to explain away the anomalies. But none of the tweaks seemed large enough to fully resolve the contradictions. The whispers about the echo grew louder. Independent groups tried to replicate the finding, analyzing Webb's raw data. A few claimed they saw it too, a faint rhythmic signature, repeating across different parts of the sky. Others argued it was an illusion, a trick of data processing, nothing more than statistical noise. Yet the possibility refused to die. If it were real, it could mean something fundamental about the structure of the universe, or something deeply unsettling. Public fascination only intensified. Amateur astronomers began scouring the images themselves, hoping to spot something overlooked by the experts. YouTube channels posted deep dives into the anomalies, mixing real science with speculation. TikTok creators shared short, hypnotic clips of Webb's galaxies, overlaid with eerie music, whispering, "What if we're not alone?" Governments, too, paid attention. While NASA maintained a careful, measured stance, other agencies quietly funded parallel studies. The European Space Agency, universities in Japan, even private foundations began pouring resources into exploring the anomalies. Everyone wanted to be the first to solve the mystery, or at least to control the narrative of what it might mean. And through it all, one truth remained constant. Webb had shown us a universe we were not prepared for. A universe that was faster, brighter, and perhaps stranger than our equations allowed. Whether the answer lay in exotic physics, unseen forces, or something beyond imagination, the telescope had delivered more than data. It had delivered wonder. As night falls and you drift deeper into thought, imagine yourself standing beneath a sky, alive with galaxies. Each one holds billions of stars. Each star, perhaps a system of worlds. The light reaching your eyes tonight has traveled for billions of years, carrying secrets older than Earth itself. And now, thanks to Webb, we see just enough of those secrets to realize how little we truly understand. In the silence between the stars, the universe seems to whisper not answers, but questions. Questions that stretch our minds, stir our imaginations, and remind us that mystery is not something to fear, but something to embrace. And perhaps, in that mystery, lies the real gift of the James Webb Space Telescope. Not certainty, but the invitation to dream. Imagine, for a moment, that everything you see in the night sky, every star, every planet, every galaxy is only a fraction of what truly exists. The universe, dazzling and vast as it appears, is like the tip of an iceberg. Beneath the surface, invisible and immeasurable by ordinary means, lies a far greater structure. Scientists call it dark matter. It's a curious name. Dark, not because it is sinister, but because it does not shine. It gives off no light, reflects no glow, and leaves no trace that our telescopes can capture directly. And yet, its fingerprints are everywhere. Galaxies spin too quickly for their visible stars alone to hold them together. Their spiral arms should fling outward, scattering into the cosmic sea, but they don't. Something unseen is binding them, an invisible glue. That glue is dark matter. When Webb's astonishing data showed galaxies forming too early, too massive, too fast, some scientists turned to dark matter for answers. Could it be that our understanding of this cosmic substance is incomplete? Perhaps dark matter is not as passive as we once believed. Maybe it played an active role in sculpting the universe's first structures. One theory suggests that dark matter may have clumped together earlier than ordinary matter, providing a kind of scaffolding on which the first galaxies could grow. Imagine invisible threads weaving a cosmic web, pulling hydrogen gas into knots where stars could ignite. If this is true, then Webb's galaxies are not anomalies. They are the expected outcome of a universe where dark matter was the architect from the very beginning. But dark matter remains maddeningly elusive. For decades, physicists have searched for it with sensitive detectors buried deep underground, shielded from the noise of everyday particles. They have built vast machines, like the Large Hadron Collider, hoping to smash particles together and glimpse dark matter's shadow. And yet, nothing conclusive has emerged. We infer its existence, not by seeing it, but by watching how it shapes the things around it. In a way, it's like wind. You cannot see the wind itself, but you can see trees bending beneath its force, waves rising across the ocean, sand shifting across a desert dune. Dark matter is the wind of the cosmos unseen, but undeniably there. As Webb peers deeper into space, it indirectly studies dark matter's role. By capturing the shapes of galaxies billions of light-years away, it lets us measure how their light is bent by gravity, an effect called gravitational lensing. The stronger the lensing, the more unseen mass there must be. Already, Webb has revealed patterns that suggest dark matter is even stranger than we imagined. It doesn't behave like a simple cloud of invisible particles. It may have interactions of its own, subtle whispers exchanged in the darkness, shaping the universe in ways our equations struggle to describe. For those lying back and listening tonight, let your imagination wander. Picture a vast, invisible skeleton stretched across the cosmos. Galaxies cling to it like dewdrops on a spider's web. Every star you've ever wished upon, every nebula you've seen in photographs, every world you've dreamed of, they all rest on this hidden framework. Without dark matter, the universe, as we know it, would never have formed. And yet, despite its importance, we cannot touch it. We cannot hold it in our hands. Its nature remains one of the most profound riddles in science. Is it made of undiscovered particles? Is it a manifestation of physics we have not yet grasped? Or is it something more radical, an illusion created by flaws in our understanding of gravity itself? The mystery deepens when we realize just how much of the universe dark matter controls. Ordinary matter, the kind that makes up stars, planets, oceans, and people, is only about 5% of the total. Dark matter accounts for nearly 27%. The rest belongs to something even more puzzling, something called dark energy, which we will explore soon. But think about that for a moment. Nearly a third of the cosmos is made of a substance we cannot see, cannot touch, and do not understand. The James Webb Space Telescope has not solved this enigma, but it has sharpened it. Its breathtaking images are not just portraits of distant galaxies. They are clues, breadcrumbs leading us deeper into the forest of the unknown. And with every discovery, one truth becomes clearer. The universe is stranger, richer, and more mysterious than we dared to believe. So as you listen and drift into a state of calm, let the thought of dark matter cradle you. Imagine invisible arms holding the galaxies together, silent but strong. A hidden embrace that keeps the stars from flying apart. It is the unseen architecture of existence, a reminder that not all truths are visible, not all realities can be measured in light. The darkness is not empty. It is full of secrets, full of answers, full of the silent substance that binds the cosmos. And perhaps, someday, we will finally learn to see it. If dark matter is the hidden skeleton of the universe, then dark energy is the breath that makes it expand. Imagine inflating a balloon. The surface stretches outward, every point moving away from every other. Our universe is that balloon, and dark energy is the invisible hand pressing air into it. The concept is almost unsettling in its simplicity. In the late 1990s, astronomers studying distant supernova expected to find that the universe's expansion was slowing down under the pull of gravity. But instead, they discovered something astonishing. The expansion was not slowing, it was accelerating. Galaxies were not just drifting apart. They were racing away from each other, faster and faster. Something unseen was driving this acceleration, counteracting gravity's pull, pushing the universe outward. That mysterious force was given the name dark energy. Here's where things become even stranger. If you could take the entire universe, every star, every planet, every galaxy and weigh it, you would find that dark energy makes up nearly 68% of the total. Think about that. Almost 7/10 of the cosmos is something we cannot measure, cannot bottle, cannot reproduce in a laboratory. It is not light, it is not matter. It is a kind of energy woven into the very fabric of space itself. The James Webb Space Telescope has given us sharper tools to study this phenomenon. By looking at distant galaxies, Webb allows scientists to trace how the expansion of the universe has changed over billions of years. The further back we look, the closer we come to the moment when dark energy first revealed itself. Webb's deep field images are not just beautiful, they're maps of cosmic acceleration. Some physicists believe dark energy might be tied to something Einstein once called the cosmological constanta, property of empty space itself. Imagine that even in the most perfect vacuum, where no particles exist, space still has an energy, a faint hum that stretches the cosmos outward. If this is true, then dark energy is not an intruder. It is part of the universe's very foundation. Others suspect something more dynamic. Perhaps dark energy is not constant but changes over time, like a tide that rises and falls. In some theories, it could even decay one day, causing the universe to stop expanding and instead collapse back on itself, a fate known as the Big Crunch. In others, it might grow stronger, tearing galaxies apart, then stars, then planets, and finally, even the atoms themselves, a cataclysm called the Big Rip. As you listen tonight, imagine lying on a beach beneath a vast star-filled sky. You hear the ocean waves rising and falling, eternal and unending. Dark energy is like that tide, but on a scale so immense it stretches the very fabric of space-time. Every moment, the galaxies drift farther apart, as though the universe itself is breathing out, wider and wider, without end. What makes dark energy so baffling is that it does not behave like anything else in physics. It has no mass in the traditional sense, no interaction with particles or light. It is invisible, yet its fingerprints are written across the cosmos. Every galaxy Webb captures, every cluster of stars, every arc of gravitational lensing, behind it all is the relentless pressure of dark energy, pushing the universe outward. Some scientists have proposed radical ideas to explain it. Perhaps what we call dark energy is not energy at all. but a sign that our understanding of gravity is incomplete. Maybe Einstein's theory of relativity, brilliant as it is, needs to be extended. In this view, the cosmos is not obeying a mysterious force, but a law of nature we have not yet uncovered. Others wonder if dark energy might be connected to the quantum world, the jittery, uncertain realm of particles smaller than atoms. In quantum physics, even empty space is never truly empty. Tiny particles flicker in and out of existence in what is called the quantum vacuum. Could these fluctuations, multiplied across the infinite vastness of space, create the push we call dark energy? The problem is, when physicists calculate this energy using quantum mechanics, the numbers are absurd by a factor of 10. That's a 1, followed by 120 zeros. It's been called the worst theoretical prediction in the history of physics. Yet somehow, the universe seems to know the correct value. It expands at just the right rate to make galaxies form, stars burn, and life emerge. Too much dark energy, and the cosmos would have torn itself apart before stars could form. Too little, and it would have collapsed long ago. And so, a haunting question lingers. Why is dark energy exactly what it is? Coincidence, or design? As you drift deeper into this story, let the paradox wash over you. Dark energy is both everywhere and untouchable. It surrounds you, it shapes you, it decides the ultimate fate of everything you know. Yet it remains nameless, faceless, a ghost at the edge of understanding. The James Webb Telescope cannot touch dark energy directly. But with each new observation, it places constraints, narrowing the possibilities, hinting at answers we cannot yet fully grasp. Perhaps one day we will understand the force that drives the cosmos apart. For now, we can only marvel at its vastness, its subtlety, its power. Close your eyes and imagine galaxies sailing across the dark sea of space, carried by a wind you cannot feel. That wind is dark energy. Silent, invisible, unstoppable. The great breath of the universe. We've wandered through the shadows of dark matter, that silent scaffold of the cosmos, and we've breathed with the mystery of dark energy, the invisible tide that stretches the universe wider. But the real wonder emerges when we place them together, side by side, and realize that they are not separate mysteries but complementary forces. They are the yin and yang of cosmic existence, opposites that define each other. Dark matter pulls, dark energy pushes. One acts like a cosmic anchor, holding galaxies together, binding stars and planets into spirals of light. The other acts like a restless wind, forever pulling those same galaxies apart, creating distance and emptiness. Without dark matter, galaxies would never form. Without dark energy, they would collapse together in endless knots of gravity. The universe exists as it does only because these two forces are in balance in eerie, delicate equilibrium. Imagine a vast stage. On one side, dark matter tugs the curtains inward, pulling everything toward the center. On the other, dark energy pushes them outward, stretching the stage wider and wider. The performance is not chaotic. It is graceful. Stars are born, galaxies collide, planets spin into orbits. All of it choreographed by the invisible interplay of forces we cannot see. James Webb's mission is like a spotlight sweeping across this stage. By looking deeper into time and space, it gives us glimpses of how dark matter and dark energy have danced together since the first act of creation. Some of Webb's earliest deep-field images already hint at the complexity of their relationship. Galaxies appear older than expected, structures more defined, suggesting that dark matter gave the universe a head start. Yet, overlaid on this, we see the unmistakable effect of dark energies stretching those galaxies farther apart, scattering them across an ever-expanding canvas. The thought is humbling. Nearly 95% of the cosmos' dark matter and dark energy combined exists outside our senses. The universe we see, the stars that inspire poetry, the planets that cradle life, the nebulae that ignite wonder, they are all just crumbs scattered across the surface of something vastly larger and stranger. The real story of existence is written in darkness, with ink we cannot yet decipher. And still, we try. We build telescopes like Webb, tuning them to infrared light so faint it has traveled for billions of years. We measure the bending of light, the shapes of galaxies, the echoes of the Big Bang itself. With every observation, we peel back another layer, hoping to glimpse the truth beneath. Yet the more we learn, the more mysterious it becomes. Dark matter holds galaxies, but what is it made of? Dark energy pushes the cosmos apart, but what is its source? Each answer births another question, each discovery deepens the enigma. There is also something profoundly poetic about this balance. If dark matter and dark energy were even slightly different, life as we know it could not exist. A little more dark energy, and the universe would have expanded too quickly, scattering matter so thinly that stars never formed. A little less, and everything would have collapsed into black holes long before Earth was born. The fact that we exist at all suggests that we live in a universe balanced on a razor's edge, where invisible forces conspire to create the possibility of consciousness. As you listen, picture yourself drifting through space. Not among the stars, but between them, in the vast void where dark matter and dark energy weave their quiet symphony. It is not a silence of emptiness, but a silence filled with purpose. Every galaxy you pass is both held together and pushed apart. Every cluster of stars the product of forces in eternal dialogue. And perhaps this is the deeper gift of Webb's discoveries, not that it gives us final answers, but that it reminds us of the scale of our ignorance and the majesty of our questions. The universe does not reveal itself all at once. It whispers in riddles, coaxing us closer, urging us to look deeper, to wonder harder, to dream bigger. So let this thought carry you as you drift toward sleep. The universe is not merely a stage for light. It is also a stage for darkness, dark matter pulling, dark energy pushing. Their interplay is not chaos but balance, not opposition but harmony. And within that harmony lies everything. The galaxies, the stars, the planets, and you. In the end, perhaps the cosmos is not asking us to solve it but to marvel at it. To let the mystery hold us, the way dark matter holds galaxies, the way dark energy carries them apart. And maybe, just maybe, in that balance, we will find not just the secrets of the universe, but a reflection of ourselves. At the center of nearly every galaxy we've observed, including our own Milky Way, there lurks something extraordinary, a supermassive black hole. These cosmic giants are not just objects of destruction. They are silent, invisible engines that shape the galaxies around them. Without black holes, the universe as we know it would be unrecognizable. Imagine the Milky Way. Our home galaxy stretches over 100,000 light-years across, filled with hundreds of billions of stars, nebulae, and planets. At its center, hidden behind a veil of dust and gas, lies Sagittarius A*, a supermassive black hole about 4 million times the mass of our Sun. For decades, astronomers could only guess at its presence. But with time, technology revealed the truth. Stars, near the galactic core, were moving in strange, rapid orbits, as if whipped around by an invisible hand. Only something immensely massive, yet unseen, could explain this machina black hole. Black holes are paradoxes incarnate. They are born from collapse, where gravity overwhelms all other forces. In their hearts lies the singularity, a point where the laws of physics as we know them break down. Surrounding that singularity is the event horizon, the point of no return, where even light cannot escape. To fall into a black hole is to vanish not just from space, but from time itself. And yet, despite their terrifying nature, black holes are also creators. They sculpt galaxies, regulate star formation, and seed cosmic evolution. In fact, galaxies and black holes appear to grow together, almost as if they are partners in some ancient cosmic dance. The more massive the black hole, the larger the galaxy, and vice versa. This relationship, known as the black hole-galaxy connection, is one of astronomy's great puzzles. How does something so small, compared to the vastness of a galaxy, exert such influence? James Webb offers us a new way to peer into this mystery. Its infrared eyes can pierce the dusty hearts of galaxies, where black holes dwell and feed. Already, Webb has uncovered quasars, black holes consuming matter so voraciously that they outshine their entire galaxies. These objects existed in the early universe, mere hundreds of millions of years after the Big Bang. Their presence challenges our understanding, because it suggests that black holes grew far faster than our theories allow. Picture it, in the young cosmos, still turbulent and wild, black holes were already there, blazing like cosmic beacons. They weren't just passive bystanders. They were active participants in shaping the first galaxies, pulling gas into their hungry mouths, blasting radiation outward, influencing how stars were born. They were engines, hidden but essential. When we think of black holes, it's easy to imagine them as cosmic monsters devouring everything in sight. But in reality, their role is more nuanced. Yes, they consume, but they also give back. As matter swirls into a black hole, it heats up and releases vast amounts of energy, often in the form of jets that shoot across thousands of light years. These jets can compress clouds of gas, sparking new star formation, or sweep gas away, preventing stars from forming at all. In this way, black holes regulate the growth of galaxies, like gardeners pruning and shaping cosmic landscapes. So as you drift into this thought, imagine black holes not as destroyers, but as cosmic engines. They are the dark hearts of galaxies, hidden but vital, pulsing with power we are only beginning to grasp. And with the James Webb Space Telescope, we stand closer than ever to unraveling their secrets. When you hear the word gatekeeper, you probably think of something guarding a door, deciding what can pass through and what must stay behind. Strangely enough, black holes often act in a very similar way on a galactic scale. They regulate the flow of matter, energy, and even time within the universe. Imagine a massive galaxy, billions of stars swirling in vast, spiral arms. At its center lies a supermassive black hole, silent and unseen. As gas and dust fall toward it, the black hole decides the galaxy's fate. Sometimes, the gas is consumed, never to return. Other times, the black hole spits matter back out in enormous jets, reaching far beyond the galaxy itself. These jets can travel at nearly the speed of light, extending for hundreds of thousands of light years, influencing neighboring galaxies as well. This is what astronomers call feedback. It sounds simple, but it is one of the most powerful processes in the cosmos. Too much feedback, and star formation shuts down, the galaxy starves. Too little, and the galaxy grows uncontrollably, unstable, burning through its resources too quickly. Somehow, black holes seem to regulate this delicate balance, shaping the long-term destiny of galaxies. The James Webb Space Telescope is beginning to give us an unprecedented look at this process. By observing in the infrared, Webb can cut through the thick curtains of dust surrounding galactic centers, revealing how material spirals into the black hole's grasp. Astronomers have already detected winds of gas, heated and flung outward by the black hole's energy, sculpting the space around them. It's as if these invisible giants are both consuming and creating simultaneously, their power extending far beyond their event horizons. There is something poetic about this dual nature. Black holes are often described as ultimate destroyers, but in truth, they are cosmic regulators. They gatekeep the growth of galaxies, deciding where stars can form and where they cannot. Without their influence, galaxies might collapse in chaos or dissipate without structure. In this sense, black holes are not just passive holes in space. They are architects of order in a universe of chaos. And yet, their role as gatekeepers might extend even further. Some physicists have speculated that black holes could be literal gateways to other places. Other times, perhaps even other universes. The mathematics of general relativity allows for such possibilities, though we have no evidence yet. Still, the idea is haunting. What if the black holes we observe at the centers of galaxies are not just cosmic regulators, but doors? What if, deep within their singularities, lies a passage to realms beyond imagination? The James Webb Telescope, of course, cannot peer inside a black hole. Nothing can. But what Webb can do is watch how matter behaves just outside the event horizon, where physics still holds. In that region, light bends, time stretches, and energy explodes in violent outbursts. The patterns we observe there may hold clue-tiny breadcrumbs, pointing us toward the true nature of black holes. Are they simply endpoints, where all information is lost? Or are they bridges to something else, something hidden, waiting for us to understand? Consider the case of quasars. These are among the brightest objects in the universe, powered entirely by black holes feeding on matter. They are so luminous that they can be seen from billions of light-years away, shining across the history of the cosmos. When Webb observes quasars, it is not just studying light, it is studying the very act of creation and destruction intertwined. Quasars remind us that black holes, far from being dark and silent, are sometimes the loudest voices in the universe. As you let this thought drift in your mind, picture the universe as a grand stage, with black holes at the center, both performers and directors. They consume and release, hide and reveal, destroy and create. They are gatekeepers not only of galaxies, but perhaps of the universe's deepest secrets. And James Webb, with its silent gaze stretched across the void, is like a patient observer at the edge of that gate, watching, recording, waiting for us to understand what lies within. For as long as human beings have gazed up at the stars, we've been driven by a simple but relentless question. What lies beyond? And of all the mysteries that the universe has given us, none has captured the human imagination more than black holes. The concept of something so dense that not even light can escape is more than just a scientific curiosity. It's a philosophical challenge. It forces us to rethink everything we know about space, time, and even reality itself. When Albert Einstein first published his theory of general relativity in 1915, he could not have imagined that its equations would predict such strange objects. At first, black holes were dismissed as mere mathematical oddities, things that could exist on paper but not in the real universe. But then came the evidence. Stars behaving oddly, as if orbiting something massive yet invisible. X-rays pouring out of regions where nothing could be seen. And eventually, direct proof. The image of a black hole's shadow, captured by the Event Horizon Telescope in 2019. That photograph, blurry yet breathtaking, was humanity's first glimpse into the abyss. The James Webb Space Telescope represents the next chapter in this quest. Unlike earlier telescopes, Webb is not limited by the distortions of Earth's atmosphere or the narrow range of visible light. Instead, it peers into the infrared, giving us a view of the universe that is both hidden and ancient. For black holes, this is crucial. Dust and gas often obscure their surroundings, hiding them from ordinary sight. Webb cuts through that fog, allowing us to witness the feeding frenzy of matter as it spirals toward the event horizon. But our fascination with black holes is not just scientific, it's deeply human. They embody our fear of the unknown, our wonder at the infinite, and our longing to explore what lies beyond the limits of perception. Myths and legends throughout history have described gateways, underworlds, and hidden realms. Today, science tells us that such gateways might exist, not in myth but in the very fabric of the cosmos. When we talk about black holes, we are not only studying astrophysics, we are also telling a story about ourselves. A story about curiosity, bravery, and the refusal to stop asking questions, no matter how frightening the answers might be. Consider what it means for a civilization like ours to look at something billions of light years away and try to understand it. The photons reaching Webb's golden mirrors have traveled across cosmic time, crossing eons to arrive at our telescope. By studying them, we are looking back not just across space, but across history itself. We are seeing the universe as it was before Earth even existed, before our sun was born, before life began. In this sense, black holes are more than just objects of study. They are time machines, letting us glimpse the earliest chapters of creation. And Webb is the tool that makes this possible. Every observation it records adds a line to the story of the cosmos. A story written in light and shadow, destruction and creation. But perhaps the most profound part of this quest is not the answers we find the act of searching itself. Humanity has always been defined by its desire to push beyond boundaries, from crossing oceans to exploring the skies, and now to peering into the abyss of space. We have never stopped reaching. Black holes remind us that the universe is bigger, stranger, and more mysterious than we can possibly imagine. And that's exactly why we keep looking. So, as you listen to this story tonight, let yourself drift into the mystery. Imagine standing at the edge of a black hole, looking into the infinite dark. You cannot see what lies beyond, but you can feel the pull, the whisper of something waiting. This is the essence of the human quest, not just to understand the universe, but to embrace the unknown, to step into the darkness with wonder instead of fear. And with James Webb as our guide, perhaps just perhaps we will uncover not only the secrets of black holes, but also the secrets of ourselves. Imagine the universe as a vast ocean, stretching endlessly in every direction. For centuries, we thought of it as scattered islands, galaxies, drifting like isolated continents across the dark sea. But the deeper astronomers look, the clearer it becomes. The universe is not random. It is structured, patterned, and connected in ways that almost seem deliberate. The James Webb Space Telescope is helping us trace those invisible threads. By peering across billions of light years, Webb allows us to see galaxies not as solitary bodies, but as part of an immense cosmic web. Picture strands of silk spun by an unimaginably large spider, each strand glowing faintly, connecting clusters of galaxies together. These filaments are made of dark matter and gas, stretching across intergalactic space. It's strange to think that most of the matter in the universe, nearly 85%, is invisible. We call it dark matter. We don't know what it is. We can't see it directly, but we know it's there because of its gravity, shaping galaxies and bending light. Without dark matter, galaxies would fly apart, unable to hold themselves together. And without the cosmic web, galaxies would not cluster into the grand structures we observe. James Webb is giving us a clearer look at these ancient filaments. When Webb looks at very distant galaxies, those that formed just a few 100 million years after the Big Bang, it's like peering at the roots of the cosmic tree. The shapes of those galaxies, their distributions, and their growth patterns all hint at the invisible scaffolding beneath them. By mapping these faint structures, Webb helps astronomers trace how the universe grew from a near-uniform soup of particles into the intricate tapestry we see today. Think of it this way. If the universe were music, the cosmic web would be its rhythm, the hidden beat guiding everything else. Galaxies are the notes, bright and loud, but the web is the invisible melody weaving them together. What's more, the cosmic web might hold the key to mysteries far deeper than structure. Some scientists speculate that these filaments could act as conduits for energy, or even as highways for matter to travel across cosmic scales. If so, the universe may be far more interconnected than we ever imagined. For now, the Webb's role is to observe, to gather light from the faintest galaxies and show us the blueprint of creation. Each infrared photon carries information about the early universe, about how stars lit up for the first time, how gas flowed into galaxies, and how black holes formed at their centers. Piece by piece, the puzzle of cosmic architecture comes into view, and as we stare at these vast, delicate filaments, we cannot help but wonder, is this structure random, or is it a sign of deeper laws, maybe even a design that we do not yet comprehend? The cosmic web stretches across billions of light years, larger than anything we can imagine, yet somehow organized, balanced, beautiful. It's humbling to think that humanity, perched on a tiny planet orbiting an average star, is now mapping the very skeleton of the universe. And Webb, silently orbiting far beyond Earth's atmosphere, is our tool for tracing those ghostly strands, revealing the hidden structures that bind everything together. When the James Webb Space Telescope first began returning its deep-field images, astronomers noticed something strange. Galaxies were not just sprinkled randomly across space, they seemed to form threads, arcs, and clusters, like beads strung on invisible lines. At first glance, it was beautiful. Upon closer study, it was deeply mysterious. This cosmic web isn't just a poetic metaphor. Observations suggest that matter in the universe flows along these filaments, drawn by gravity into knots where clusters of galaxies form. Imagine rivers feeding into vast lakes. The filaments are the rivers, the knots are the lakes, and galaxies are the settlements along their shores. Without these flows, galaxies might not have grown into the enormous structures we see today. And yet, the more Webb peers into this structure, the more questions arise. For one, the size of some of these filaments seems larger than what our cosmological models predict. Could it be that the universe is more ordered than chance allows? Or that some unknown force is shaping its geometry? Astronomers often talk about dark matter as the hidden glue. But even dark matter is not enough to fully explain what Webb is seeing. There may be other ingredients: dark energy, quantum fluctuations, or even exotic physics that we haven't yet dreamed of. Webb doesn't answer the mystery. It sharpens it. And then there's the most haunting possibility. What if this vast interconnected structure is more than just physics? Some thinkers, both scientists and philosophers, speculate that the cosmic web resembles the neural network of a brain, viewed at the largest scales. The structure of the universe, galaxies linked by filaments, looks eerily similar to neurons linked by synapses. If you compare an image of the human brain with a simulation of the cosmic web, the resemblance is uncanny. Could it be coincidence? Almost certainly. But it forces us to confront a staggering question. Is the universe itself a kind of mind? Is it conscious in some way we cannot yet grasp? Or perhaps, are we tiny thoughts inside an unimaginably vast intelligence? Webb does not claim to prove such things, but what it does is give us data, sharper and more detailed than ever before, so we can see the canvas more clearly. Every galaxy Webb captures becomes another data point in the grand design. And as the picture fills in, we are left with an impression that is both scientific and deeply existential. The universe is not chaos. It has form. It has hidden order. Even the light itself seems to conspire to reveal these patterns. Photons that have traveled for billions of years, stretched into the infrared by cosmic expansion, arrive at Webb's golden mirrors and whisper stories of their origins. These whispers add up, forming maps of the early universe that reveal a design too vast for human imagination. The thought that we are capable of seeing this is astonishing. Just a few hundred years ago, people believed the stars were fixed points on a crystalline dome. Now, thanks to Webb, we can see across almost the entire observable universe, tracing the cosmic web itself. Humanity has leaped from myth to measurement, from wonder to understanding, yet the wonder has only deepened. The more structure we find, the harder it is to dismiss the sense that something profound lies beneath it, whether that something is physical law, hidden dimensions, or even a reality beyond our own. Webb is bringing us closer to asking the right questions. As Webb continues to gather light, what becomes increasingly clear is that the universe is not only vast but interconnected in ways we are just beginning to grasp. Each faint galaxy, Webb records, becomes a piece of the puzzle, fitting into patterns that stretch across unimaginable distances. One particularly striking revelation comes from observing galaxy clusters. These clusters are not isolated, they act like cosmic hubs, nodes in the web. The gravity of these clusters is so intense that it bends light itself, creating what we call gravitational lensing. Through these cosmic magnifying glasses, Webb can peer even deeper into the universe, revealing galaxies that would otherwise be invisible. In a sense, the Webb reveals itself through its own distortions. And yet, even with these breathtaking observations, the enigma deepens. Why does the Webb look the way it does? Simulations suggest that it all began with quantum ripples in the earliest moments of the Big Bang, tiny fluctuations that grew, stretched, and eventually became the scaffolding for galaxies. But some of Webb's findings hint that the structure might be too mature, too developed, too soon after the Big Bang to match our models. Could our understanding of cosmic history be missing a chapter? Another question that lingers. If dark matter shapes the Webb, then what shapes dark matter? We don't know what dark matter is. It could be exotic particles, hidden dimensions, or something even stranger. Webb doesn't detect dark matter directly, but it shows us its fingerprint, the way it molds the light and matter we can see. And in those fingerprints, scientists sometimes find hints that something doesn't quite add up. It's almost as if the universe is a grand tapestry, but the threads are made of materials we cannot touch or see. We can admire the design, but we do not yet know the weaver. For those listening tonight, drifting towards sleep, perhaps the image of the cosmic web can be a comforting one. Imagine lying beneath the night sky, knowing that every star, every galaxy, every particle of dust is part of a greater whole. The same forces that bind distant galaxies into filaments also shape the matter in your body. The atoms in your bones once floated in those same cosmic rivers of hydrogen and helium. You are, in a very real sense, a child of the Webb. And as Webb sharpens its gaze, we draw closer to seeing not just our origins, but perhaps our place in the cosmic structure. Some scientists dream that one day, by mapping the Webb in exquisite detail, we might uncover hidden truths about the fate of the universe, whether it will expand forever, collapse back into itself, or transform into something else entirely. But until then, the Webb remains a mystery, a delicate, intricate, and hauntingly beautiful mystery, stretching across billions of light years, binding us all together in ways we are only beginning to perceive. James Webb is not just showing us the universe, it is showing us the connections that make the universe whole. And in those connections, we glimpse not just physics, but meaning, something that lingers with us long after the images fade from the screen. Something that follows us into dreams as we drift into sleep. The night sky has always appeared timeless to the human eye. Stars seem fixed in their constellations. Planets wander slowly across the heavens, and the Milky Way arches like a river of light. But what the James Webb Space Telescope confirms is that the universe is anything but still. It is expanding, stretching, and accelerating in ways that defy our intuition. This story begins in the 1920s, when astronomer Edwin Hubble discovered that galaxies are not static, they are moving away from us, and the farther they are, the faster they recede. The universe, it seemed, was expanding. For decades, scientists debated what this expansion meant. Would gravity eventually pull everything back together, ending in a fiery collapse? Or would expansion continue forever, galaxies drifting farther and farther apart until the night sky grew empty? Then, in the late 1990s, came a shocking discovery. The expansion of the universe is not slowing down, it's speeding up. Something unknown, something powerful is pushing galaxies apart faster and faster. Scientists called it dark energy. Webb, with its infrared eyes, offers one of the best tools for probing this mystery. By looking at the most distant galaxies and supernova, Webb helps measure how fast the universe was expanding at different times in its history. These cosmic snapshots reveal an accelerating expansion that cannot be explained by gravity or ordinary matter. Dark energy makes up about 70% of the universe. Let that sink in. Most of what determines the fate of everything, the stars, the galaxies, even time itself, is a force we cannot see, cannot touch, and cannot fully understand. It is as if the cosmos is haunted by an invisible wind, pushing everything outward into deeper emptiness. But here is where the story grows even stranger. Some theories suggest that dark energy might not be constant. It could evolve, grow stronger, or fade away. Others propose it is linked to the very fabric of space-time, the energy of the vacuum itself. Still others whisper of hidden dimensions or exotic fields that tug at reality in ways we cannot yet imagine. Webb is not designed to detect dark energy directly, but what it can do is map the growth of structure in the universe, the way galaxies cluster, the way filaments form, the way gravity competes with this mysterious push. By studying the balance between matter and expansion, Webb sharpens the outlines of the unknown. And here is the haunting thought. If dark energy grows stronger over time, the universe may face a fate known as the Big Rip. Galaxies would be torn from clusters, stars pulled from galaxies, planets ripped from their orbits, even atoms themselves shredded by expansion. Everything, down to the smallest particle, would be unbound. On the other hand, if dark energy fades, the universe might slow its expansion and drift toward a quiet freeze. Galaxies would still drift apart, stars would burn out, and darkness would settle, but in silence rather than violence. For now, we do not know which path awaits us. All we know is that the James Webb Space Telescope is helping us refine the map of our cosmic destiny, one faint galaxy at a time. As you close your eyes tonight and listen, imagine space itself stretching around you, every second carrying galaxies farther apart. The expansion is not something happening out there, it is happening everywhere. Even between the atoms in your body, though too subtly to notice. The universe is not a static stage. It is a living, restless entity, and dark energy is its hidden heartbeat. If dark energy represents the invisible hand pushing the cosmos apart, then the James Webb Space Telescope is like a lantern carried into the fog. Its light doesn't banish the mystery, but it illuminates the outlines of something vast and strange. Astronomers use Webb to study galaxies so distant that their light has traveled for over 13 billion years. These galaxies formed shortly after the Big Bang, when the universe was still a cosmic infant. By comparing how galaxies were arranged then to how they are arranged now, scientists can track how the expansion of space has evolved. One of Webb's tools, the near-infrared camera, NIRCam, captures light from these ancient galaxies, stretched into the infrared by billions of years of cosmic expansion. Every faint smear of light Webb records is a marker of time, a checkpoint in the long journey of the universe. And when scientists line up these checkpoints, a pattern emerges. The speed of expansion has not been constant. It has shifted, surged, and accelerated, as though the universe has moods we are only beginning to understand. This is where the puzzle deepens. Different ways of measuring the expansion give slightly different answers, a discrepancy known as the Hubble tension. The Hubble Space Telescope measured one rate. Webb sharpens that measurement. While observations of the cosmic microwave background, the faint afterglow of the Big Bang, suggest another. Why do these numbers not agree? Is there an error in our methods, or does this tension point to new physics? A hidden layer of reality waiting to be uncovered. Imagine standing on a beach, watching waves approach. If two observers disagree on how fast the tide is rising, the difference might not be a mistake, it might mean there is something more complicated happening beneath the surface of the ocean. In the same way, this cosmic tension could signal a deeper truth about dark energy, about gravity, or about the fabric of space itself. Some scientists suggest that what we call dark energy may not be a simple, uniform field. Instead, it could be dynamic, shifting in strength as the universe grows older. Others imagine exotic particles or fields filling space, subtle but relentless, like an invisible ocean we swim through without realizing it. And then there are the most daring ideas, the thought that our universe might not be alone, that what we call dark energy is the tug of other realities, parallel universes brushing against ours, their gravitational influence spilling into our cosmic ocean. To Webb's instruments, these are just numbers, faint smears of ancient light, but to human imagination, they are doorways into possibilities we can barely whisper about. As Webb continues to stare deeper into the abyss, its findings ripple back to Earth, forcing us to re-examine not just our models of physics, but our understanding of existence. If most of the cosmos is controlled by something invisible and untouchable, what does that say about our place in it? Are we clinging to a tiny island of certainty while surrounded by an ocean of the unknown? There is a quiet humbling in this realization. When you lie back and gaze at the stars, or perhaps simply close your eyes as you drift towards sleep, you are part of a universe in motion, a universe driven by forces we cannot yet define. Every heartbeat, every breath, happens inside a cosmos that is not just expanding, but accelerating, propelled by a hidden current that Webb helps us trace but not yet grasp. And so the mystery remains. What is dark energy? A property of space, a ghostly field, a signal from beyond our universe, or something stranger still, something our minds have not yet learned how to imagine? To truly appreciate what the James Webb Telescope is showing us, we need to step back and think about what it means to measure the universe itself. Human beings evolved to understand the world on scales of meters and seconds, things we can touch, see, or count. But the universe demands that we stretch our perception to billions of light years and billions of years. Webb is not just a machine. It is a translator, taking the silent language of light that has crossed time itself and rendering it into data we can interpret. When Webb captures the faintest glimmer from a galaxy 13 billion years away, that photon of light has been traveling longer than Earth has existed as a planet with life. It has passed through expanding space, dodged cosmic dust, and finally been caught by mirrors floating in the cold darkness beyond the moon. In that single speck of light, astronomers find a message: how fast the universe was growing when that light began its journey, how galaxies were clustering, how matter and energy were distributed. And yet, the message does not line up with what we thought we knew. The Hubble tension, as scientists call it, is not a small problem. It is like looking at a map and realizing two cities are marked at the same location, even though travelers swear the journey between them is long. Something is inconsistent. Webb's clarity makes the inconsistency sharper, not smoother. The data confirms both sides, and in doing so, deepens the mystery. For some, this is frustrating. For others, it is thrilling. Science has always advanced when contradictions force us to abandon the comfort of old assumptions. Perhaps Einstein's equations of gravity are not the full story. Perhaps dark energy is not a static force, but a dynamic field, evolving with time like a living organism. Or, perhaps, in the most radical visions, our cosmos is part of a larger structure, a multiverse, with hidden dimensions influencing what we see. Think of it like hearing a faint echo in a cave. You expect the echo to match the shape of the cavern, but instead, it reveals another chamber beyond, one you didn't know existed. Webb's discoveries may be those echoes, clues that space is larger, stranger, more layered than we dared to dream. For those listening tonight, perhaps already drifting towards sleep, consider the serenity of this paradox. The universe is not simple. It is not easy, and yet, it invites us to explore, to wonder, to stretch our minds beyond their natural limits. We may never hold dark energy in our hands, but we can feel its presence in the accelerating stars, in the restless galaxies, in the silent expansion that Webb charts with its golden mirrors. In the end, the mystery of dark energy may not just be about physics, it may be about perspective, about realizing that our understanding is always provisional, always growing. Just as ancient navigators once believed, the ocean ended at the horizon, only to discover entire continents beyond. We may one day discover that what we call dark energy is just the edge of something greater, a horizon of understanding waiting to be crossed. As you close your eyes, imagine the telescope out there now, orbiting in silence, its mirrors catching ancient light. Somewhere in that data, in those faint signals from the edge of time, lies the answer to one of the greatest riddles of existence. Until we uncover it, we remain voyagers in the dark, guided by curiosity, humbled by the unknown, and strangely comforted by the thought that the universe still has secrets left to tell. Picture the silence of space. Out there, far beyond the hum of Earth, beyond the air we breathe, and the oceans that churn, hangs a machine of gold and steel. The James Webb Space Telescope drifts in its orbit around the second Lagrange point, balanced between gravity and sunlight. From that still vantage point, it opens its golden mirrors to the universe, listening for light that has traveled for billions of years. What Webb finds is not always what we expect. In the earliest months after its deployment, scientists believed its greatest gift would be sharper images of galaxies we had already glimpsed. Instead, it revealed entire populations of galaxies that should not exist, galaxies too massive, too structured, too early in cosmic history. These were not the faint smudges we imagined from theory. They were intricate, star-forming systems, as if the universe had rushed to build complexity faster than our models allowed. This single observation sent shockwaves through cosmology. For decades, astrophysicists had a timeline of cosmic growth. First the Big Bang, then the cooling plasma, the birth of hydrogen, the formation of stars, and only much later, galaxies assembling into clusters. But Webb was telling a different story. In its deep fields, within just a few 100 million years after the Big Bang, there were galaxies shining as brightly as the Milky Way. Their mass and structure implied that the universe wasted no time in constructing vast cities of stars. How could this be? To create such galaxies so quickly, matter must have collapsed more efficiently, or dark matter must have behaved differently. Or perhaps the physics of early star formation is stranger than we thought. Each explanation invites new questions. Imagine standing on a beach, tossing sand into the wind. You expect the grains to fall slowly, to gather into tiny dunes over time. But Webb is showing us towering dunes already sculpted, vast structures that should have taken eons to form. Did gravity work harder in the early universe? Did unknown forces compress gas and dust into stars more urgently? Or is our very picture of time, expansion, and evolution incomplete? This is where the human imagination collides with the evidence of the skies. For many scientists, Webb-esque galaxies feel like a message from the cosmos. You still don't know me. Each observation is a whisper from the past, saying that the story of the universe is more intricate than the tidy charts and equations we grew comfortable with. At the same time, the telescope is confirming mysteries we already suspected. The distribution of galaxies, the strange smoothness of the cosmic microwave background, the accelerating expansion, all of these remain consistent. And yet, when Webb looks deeper, it sees anomalies hiding beneath the surface. It is as though the universe wears a mask of order, while chaos and enigmas simmer underneath. For you listening now, imagine those galaxies twinkling, not as cold data points, but as ancient lanterns. Their light left before Earth was born, before the sun was even a dream of stardust. That light wandered the cosmos, stretched by expansion, faint but persistent. And then, at last, it struck Webb's mirrors and entered our world. In that moment, we are connected to the very edge of creation itself. What Webb has given us, perhaps more than numbers or charts, is a reminder that the universe is alive with surprises. That even when we think we've mapped the stars, the cosmos holds secrets just beyond the horizon of certainty. Each mystery is not a wall, but a door, waiting for us to open it with questions bold enough to match the grandeur of the sky. When the first wave of data from Webb was released to the public, the scientific community buzzed with both exhilaration and unease. The images were breathtaking, filled with swirls of galaxies, glowing nebulae, and the faint fingerprints of starlight older than human history. But beneath the beauty, something was off. The sheer abundance of massive galaxies appearing so early in cosmic time clashed with decades of predictions. In cosmology, expectations are carefully modeled. Simulations have run on supercomputers for years, tracing the dance of dark matter halos, the slow condensation of hydrogen gas, the gradual ignition of stars. These models produce timelines. Galaxies should take billions of years to grow, clustering into the magnificent spirals and ellipticals we see today. Yet Webb's findings suggest the universe built its cities of light in record time, as if skipping steps in a script we thought we knew by heart. It's worth pausing here. Imagine reading a mystery novel and reaching chapter 3, only to discover the villain has already revealed their plan. The climax is already underway. That is how many astronomers feel like the universe is racing ahead of its own story. Something about the way matter behaved in those first few 100 million years must have been different. Some argue that the physics of star formation might change under extreme conditions. Perhaps the density of gas was so high, the pressure so immense, that stars bloomed like wildfires rather than flickering candles. Others propose that black holes played a larger role, acting as engines of early structure, their immense gravity gathering material quickly into dense regions that formed galaxies more rapidly. But there are stranger ideas as well. A few astrophysicists wonder if the cosmic expansion rate itself might not have been as steady as we assumed, if the laws of physics were even slightly different in that primordial era if gravity pulled harder, or if dark energy had not yet awakened then. Galaxies could have assembled much faster. It is a delicate suggestion, one that hints at new physics, but it is not dismissed outright. Webb's data demands we entertain possibilities once considered fringe. There's another wrinkle. The light Webb collects is ancient, but interpreting it requires models of distance and redshift. If our calibration of cosmic distances is flawed, even by a small fraction, then our entire timeline shifts. Galaxies we thought were impossibly old may not be as old as they appear. Still, even with this possibility, the scale of the discrepancy remains unsettling. As debates ripple through conferences and journals, a pattern emerges. Scientists are split between cautious revision and bold reimagining. Some hold fast, adjusting existing models in the hope that small tweaks will reconcile theory with Webb's vision. Others see this as a chance to revolutionize cosmology, to propose daring alternatives that question the very fabric of spacetime. And while experts argue, the public watches in awe. For those outside the scientific circles, Webb is not just a telescope, it is a storyteller. Its images feel like postcards from the edge of time, each one reminding us that the universe is bigger, stranger, and more alive than we ever dared to dream. Consider for a moment the emotional weight of these discoveries. For a scientist who has devoted decades to building simulations, Webb's data may feel like betrayal. For a young student just entering the field, it may feel like liberation of fresh canvas where imagination can run wild. This tension between expectation and discovery is not a failure. It is the heartbeat of science. The cosmos refuses to be ordinary, and so our task is to grow extraordinary enough to follow it. Lying here, listening to this story, let yourself drift into that duality. The comfort of knowledge and the thrill of mystery. The stars are not only above us, they are questions written in light, waiting for us to read them anew. Think of the Webb telescope not as a cold machine, but as an extension of our human curiosity. Each golden mirror is like an eye opening wider, daring to stare into the deep abyss of creation. And what it sees challenges not only our equations, but our sense of place in the cosmos. Let us imagine, for a moment, that the anomalies Webb is revealing are not errors of interpretation, but messages. Not deliberate messages, of course, but natural signals, carved into the starlight by the hand of the universe itself. Each spectrum, each faint galaxy, each unexpected brightness is like a syllable in a story written across billions of years. We are just beginning to learn the language. Among these signals, some scientists whisper about the possibility of hidden structures, patterns too subtle to dismiss. Could the distribution of galaxies suggest rhythms in cosmic formation, echoes of something deeper than random chance? The mind races toward possibilities. Remnants of earlier universes, scars from primordial collisions, or even imprints of dimensions we cannot see. These are ideas that border on the fantastical, and yet, when faced with Webb's contradictions, imagination is not a luxury but a necessity. We can recall that science has been here before. When Hubble revealed the accelerating expansion of the universe in the late 1990s, it was a shock that birthed the concept of dark energy. What was once unthinkable became mainstream within a decade. Perhaps Webb is laying the groundwork for another revolution. What if its data is the seed of a new paradigm, where our current understanding of cosmology is only a shadow of a deeper truth? For those listening, drifting in the quiet of this narrative, let this thought linger. The universe is under no obligation to make sense to us. It is vast, indifferent, and yet filled with patterns we yearn to understand. That yearning is what keeps us looking up, building telescopes, launching them into the void. Webb is a vessel of that longing, a reminder that to be human is to seek the unknown, even while wrapped in the fragility of sleep. And still, there is humility. Each time we think we have cornered the cosmos with our theories, it slips away, showing us galaxies that should not exist, stars that are too old, black holes that are too massive. Webb does not give us final answers. It gives us sharper mysteries. That is its greatest gift. So as you close your eyes, imagine those galaxies Webb has shine brilliant clusters shining against the darkness. Picture their light, older than any mountain on Earth, older than the oceans, older than the very atoms in your body. That light traveled across time, not for you, not for me, but simply because light moves forward. And yet, by chance, here we are to catch it, to wonder at it, to let it reshape the way we dream. What lies beyond explanation is not just out there among the stars. It is also within us the capacity to marvel, to admit ignorance, and to find beauty in questions without answers. Webb has reminded us that the cosmos is stranger than our myths, deeper than our equations, and more generous than our imaginations. And that reminder is perhaps the most comforting lullaby of all. There is a rhythm to human history that echoes with every discovery, every time we dared to look farther than before. When we first looked up at the night sky, the stars were not distant suns, but gods, ancestors, or lanterns fixed in the heavens. The sky was a stage for myth, and humanity was at its center. Then, as centuries passed, the myths gave way to questions, and the questions gave way to telescopes. With every improvement in glass and lens, with every step higher into the mountains, we moved further from certainty and deeper into wonder. It is worth remembering how disruptive each revelation was. when Copernicus suggested that Earth was not the center of the universe, but merely one planet orbiting the sun, it was not just a scientific statement, it was a wound to human pride. The ground beneath us felt less secure, and yet, in that insecurity, we grew. Later, when Galileo lifted his telescope and saw the moons circling Jupiter, the heavens were no longer perfect spheres, but dynamic, chaotic, alive. Each discovery forced humanity to rewrite not only its science but its philosophy, its sense of purpose, its very identity. Fast forward centuries, and Hubble's deep field images performed the same trick. Where we once saw darkness, Hubble showed us thousands upon thousands of galaxies, stretching beyond imagination. It was like staring into infinity, a reminder that the Milky Way is not the whole, not even a large part, but a single brushstroke on an endless canvas. That discovery shook us again, not with violence, but with humility. And now, James Webb continues this tradition. What Webb has detected so far? Those galaxies that should not exist. Those stars that seem impossibly old reminds us that each new lens onto the cosmos comes with a price. We must abandon our illusions of certainty. What does it mean that the universe appears stranger than our theories predict? What does it mean that the very laws we rely on to explain existence may need rewriting? These questions are not confined to laboratories or lecture halls. They filter into culture, into art, into late-night conversations where people wonder if the cosmos has room for meaning, for design, for something more than randomness. Every civilization has tried to place itself within the larger story. The ancient Egyptians built monuments aligned with the stars, binding heaven and earth. The Mayans tracked the movements of Venus as if its rhythm carried destiny. Even the medieval cathedrals of Europe, with their stained glass windows, were attempts to capture a cosmic order in light and stone. And here we are, in the 21st century, not with pyramids or temples, but with a golden telescope drifting a million miles away, seeking the same thing: to understand where we belong. The irony is that with every advance, the universe becomes less anthropocentric. We learn we are smaller, more fragile, less central than we believed. Yet at the same time, our ability to perceive grows larger. We are specks of dust who can measure the light of galaxies born when the universe was still a child. We are temporary beings who can contemplate eternity. That paradox that we are insignificant and yet capable of cosmic thought is, perhaps, the most profound gift of science. Webb, then, is not only a telescope, it is a mirror. What it reflects back to us is not just light from the distant past, but the shape of our own curiosity. It forces us to face questions as old as philosophy itself. Are we alone? Is the universe infinite? Does it have meaning? And perhaps the most humbling of all, will we ever truly know? These are not easy questions, and yet they are beautiful in their difficulty. Each culture, each era, has answered them differently. But with Webb, the answers are not carved into myth or legend. They are etched in spectra, in redshifts, in the faint glow of galaxies too small to be seen before. And still, the awe is the same. The wonder is the same. We sit under the night sky, whether in ancient deserts or modern cities, and feel that same tug of mystery. As you drift in this story, imagine those who came before us, staring at the same stars without knowing what they were. Imagine the courage it took to suggest that Earth was not the center. Imagine the fear, the resistance, the upheaval. And then remember that Webb may be doing the same for us now. Its discoveries might feel impossible, even threatening. But they are also invitations to grow, to think bigger, to embrace the unknown as part of our journey. So perhaps the lesson is this: each time the cosmos unsettles us, it is not to diminish us, but to expand us. Each time the universe contradicts our models, it is giving us a chance to dream wider. And in those dreams, humanity finds its truest self, not as rulers of creation, but as explorers of its endless depths. While Webb is a machine of science, its impact stretches far beyond equations and data charts. Science, at its best, does not only answer questions, it inspires imaginations. Think of how many works of art, novels, films, and even musical compositions were born from glimpses of the cosmos. A single photograph of Earth from space, the pale blue dot, changed how generations thought about fragility, unity, and the preciousness of life. Webb is beginning to do the same, and perhaps on an even larger scale. Consider the first images Webb released: galaxies stretched like arcs of glass, nebulae that looked like cosmic mountains glowing in starlight, clusters of stars sparkling like jewels. These images went viral, not because the public understood the technical significance, but because they were beautiful. They looked like paintings of eternity. They reminded people that, no matter the chaos on Earth, the universe remained vast, luminous, and full of mystery. This is the power of imagery. Before Webb, deep space was mostly abstract numbers on a page, simulations and software. But when those golden mirrors opened and captured light that had traveled for billions of years, the abstract became tangible. Suddenly, the cosmos was not only for scientists, it was for poets, filmmakers, dreamers, and children gazing at a screen, their eyes wide with wonder. Webb democratized the mystery of the universe. Art responds to this. You can already see it: painters blending Webb's nebulae into their canvases, musicians composing symphonies inspired by galaxies, writers weaving its discoveries into stories of love, loss, and transcendence. Even those who never read a scientific paper still feel connected to the telescope because it speaks the universal language of beauty. Science, when framed by imagination, becomes not only knowledge but nourishment. It also reshapes our myths. Ancient cultures looked to the stars and told stories of gods and heroes. Now, we look to Webb's images and find stories of origins, of cosmic evolution, of a universe in motion. These are the myths of our era, not myths in the sense of falsehoods, but myths as narratives that give meaning to our place in the cosmos. And just like the old myths, these new ones guide us, inspire us, and help us fall asleep at night with a sense that we are part of something vast. There is also comfort here. For many, the universe can feel cold, indifferent, even hostile. Black holes devour, stars explode, galaxies collide. And yet, through Webb's lens, this chaos becomes art. A dying star becomes a glowing tapestry. A galactic collision becomes a dance of light. Even the violent processes of the universe, when seen from afar, reveal patterns of elegance. What could be more reassuring than to know that beauty persists even in destruction? This beauty feeds not only culture, but also philosophy. Questions that once belonged solely to science: where did we come from? What else is out there? Become shared across classrooms, cafes, and late-night conversations. Webb's discoveries blur the line between the scientific and the existential. Each new anomaly is not just a challenge to astrophysics. It is a meditation on what it means to be alive in a universe so strange. And then, there is the personal dimension. Imagine a child seeing Webb's images for the first time. To them, it is not a data set but a portal. They may dream of becoming an astronaut, or a scientist, or perhaps simply carry with them the quiet knowledge that the world is bigger, richer, than it seems. That seed of curiosity, planted in countless young minds, may bloom into tomorrow's revolution, technological, artistic, or philosophical. In this way, Webb is less a telescope and more a bridge between past and future, between science and art, between knowledge and wonder. It reminds us that exploration is not only about survival or utility, it is also about feeding the soul. We explore because to stop exploring would be to stop dreaming, and to stop dreaming would be to stop being human. So as you relax into this story, let Webb's images drift into your imagination. Let the arcs of galaxies, the pillars of stardust, and the infinite points of light settle into your mind as though they were painted there. They are not just data. They are reminders that even in an age of technology, wonder is still possible. And sometimes, wonder is exactly what we need most. The James Webb Space Telescope does more than capture images. It changes the way we think about time itself. Every photograph it takes is not a snapshot of now, but of then. A galaxy Webb reveals tonight may have sent its light across billions of years, traveling through a universe that has since stretched, cooled, and evolved. By the time that light reaches Webb's golden mirrors, the galaxy itself may no longer exist in the same form. This realization reshapes our sense of presence. When you look at a Webb image, you are not looking into space, you are looking into history. Each point of light is a story frozen in time, a memory of a cosmic moment long past. In this way, Webb is both a telescope and an archive. It preserves the whispers of ancient stars, letting us read them as though we were leafing through the pages of a universal diary. And what does this diary tell us? That the universe is not static but alive, always becoming. Stars are born, they shine, they die. Galaxies grow, collide, merge, and transform. Patterns emerge, spirals, clusters, filaments, stretching like threads across unimaginable distances. Through Webb, we see not only what is, but what was, and we can even begin to imagine what will be. This sense of time expands our imagination. It makes our daily concerns feel small, but not in a way that diminishes us. Instead, it liberates us. To know that stars have lived and died before Earth was even formed is to realize that change is natural, that impermanence is part of the grand design. Just as galaxies evolve, so do we. The universe is in motion, and so are our lives. Philosophers might say Webb is a mirror, reflecting not only the cosmos but our own search for meaning. When we marvel at distant galaxies, we are really marveling at the fact that we are here, capable of seeing them, capable of wondering. The telescope reminds us that consciousness is itself a cosmic phenomenon. Out of stardust came eyes, and through those eyes, the universe looks back at itself. There is an intimacy in this. The farther Webb sees, the closer we feel to something eternal. We are not just viewers, we are participants in a cosmic dialogue. The light from distant galaxies calls out, and our technology answers by receiving it, decoding it, giving it form. In a sense, Webb is humanity's ear pressed against the wall of infinity, listening carefully for echoes. This intimacy also extends to our dreams. For centuries, humans have asked whether we are alone, Webb cannot yet tell us for sure, but it does expand the possibilities. By studying exoplanets, analyzing their atmospheres for hints of life, Webb teases at the question. Somewhere, in a spectrum of light captured quietly in the dark of space, could be the faint fingerprint of biology. A trace of something breathing, moving, existing under another star. Whether Webb finds such evidence or not, the act of searching is itself profound. It tells us that curiosity is part of what makes us human. We long to connect, to know if the story of life is unique or shared. Webb embodies that long in it is our question written in gold, orbiting far from Earth, whispering across the stars. Is anyone else out there? But Webb's gift is not only in the answers it may give, it is in the perspective it provides. To see Earth as a fragile dot among billions of galaxies is to be reminded of both our vulnerability and our resilience. We may be small, but we are not insignificant. Out of all the places in the universe, we are here, aware, capable of love, creativity, and wonder. That alone makes our existence extraordinary. And so, as you drift deeper into this story, let Webb's journey become part of your own. Imagine the telescope floating silently in the cold of space, its mirrors unfolding like petals of a golden flower, absorbing light that has crossed the eon. Imagine those photons, ancient travelers, finally arriving, transformed into images that reach your eyes, your mind, your dreams. In this quiet moment, you and the universe are connected. You are not separate from the stars, but part of them. The hydrogen that burns in distant suns is the same hydrogen that flows in your veins. The carbon in your body was forged in the hearts of ancient stars that died long ago. Webb shows us this truth, not through poetry, but through science. Yet the poetry is there all the same. As the telescope peers deeper, humanity peers deeper with it. We are learning, discovering, questioning, but we are also remembering that we belong to the cosmos, that we are threads in its vast tapestry, that our story is woven into the fabric of space and time. Webb is not just an instrument of discovery. It is a reminder of belonging. And perhaps that is its greatest mystery, not what it shows us out there, but what it awakens in here. When we imagine the James Webb Space Telescope drifting silently in the void, it can feel almost like a dream. Suspended a million miles from Earth at its special orbit, it does not roar like a rocket or thunder like a machine. It does not flash, or hum, or shout its presence into the universe. Instead, it waits. It listens. It gathers. In this silence, Webb becomes a reminder of the nature of discovery. Discovery is not always dramatic, it is often patient. Just as the telescope holds steady, capturing photons one by one, so too do we make sense of our place in the cosmos, slowly, quietly, over time. Knowledge is not rushed, it is collected, refined, and nurtured, like starlight gathered in the dark. This patience leads us to a humbling realization. The universe is vast beyond measure, and yet, within its immensity, it holds stories for us. Webb shows us that the cosmos is not indifferent. It leaves traces of its history everywhere on the glow of ancient galaxies, in the ripples of cosmic dust, in the faint signatures of molecules drifting around alien suns. These are gifts, waiting to be seen, waiting to be understood, and when we receive them, something changes in us. To witness the birth of stars through Webb's eyes is to sense the poetry of creation. To gaze at galaxies colliding is to understand both destruction and renewal. To study the atmospheres of distant planets is to confront the possibility that life somewhere, somehow might be looking back at us. The mystery grows deeper the more we learn. It's as though the universe has designed itself to be inexhaustible, always leaving us with more to wonder about. Every answer Webb provides seems to open to new questions. We are not nearing the end of discovery, but the beginning of a new era, an era where the hidden is unveiled and the impossible feels closer. But perhaps the most beautiful lesson Webb offers is not cosmic, it is human. The telescope exists because countless people believed in the value of wonder. Engineers, scientists, artists, dreamers all devoted decades to an idea that we could build a machine capable of touching the edge of time. That faith, that persistence, is a reflection of what humanity can achieve when we dream together. In that sense, Webb is not just a triumph of science, but of imagination. It embodies our desire to look beyond the horizon, to reach past the visible, to understand not only what the universe is, but what it means. It reminds us that exploration is not just about knowledge, but about connection to the cosmos, to each other, and to the mystery that lies within ourselves. So, as you listen now, let yourself feel that connection. Imagine floating alongside the telescope, surrounded by a sea of stars. The Earth is far away, a tiny glowing marble, fragile and precious. Ahead of you stretches infinity, galaxies upon galaxies, veils of light and shadow, a canvas painted over billions of years. Webb is your guide, but you are the witness. Allow this vision to soften the edges of your thoughts, the worries of the day, the noise of the present, the weight of your own story. All of it becomes lighter against the backdrop of the universe. The stars do not hurry, and neither must you. Time stretches gently here. You are part of a rhythm older than any planet, older than any star. You are part of the great unfolding. The telescope continues its watch, gathering light, deepening our understanding. And as it does, it invites us to dream not only about what we will find, but about what we will become. Perhaps, one day, humanity will step into those distant worlds Webb has only glimpsed. Perhaps we will walk under alien suns. Or perhaps, simply knowing that they exist will be enough to remind us of the miracle of our own existence. In either case, the mystery endures. The universe will always hold more than we can see, more than we can measure, more than we can name. And that is not a limitation, but a gift. For in mystery lies wonder. And in wonder lies peace. So let Webb's golden mirrors fade into your imagination. Let the stars scatter like embers across the dark. Let yourself drift deeper, quieter, as though you too are traveling through space, unbound, timeless, free. The journey does not end. It continues, always, in the vast silence between the stars. And perhaps, if you listen closely, you can hear it, the soft whisper of the cosmos, calling not for answers, but for awe.